In this lesson, we will attempt to answer the question, what is a derivative? Derivative. And I'll give you the answer right up front. The derivative is simply the slope of a function. That's it. All the fear and all the complexity associated with derivatives and integrals is unfounded because it is simply the slope of a function. And if you keep that in mind while you study Calculus 1, your life will be much more simple. So let's jump right in and let's draw a graph. So we have the y-axis, the x-axis, and we draw the line y equals mx plus b. Okay, now what would be the slope of this line? How would we calculate the slope? So the slope is simply the rise over the run. So let's write down our different definitions of slope. Rise over run, or the change in y over the change in x, or so delta, the delta symbol or triangle symbol means change. That's simply the change in y versus over the change in x. And then another definition for the slope would be the rate of change. So all of these different ways we use to describe the slope. And this slope, y equals mx plus b, is a straight line. So it's very straightforward. The slope is the same on every point of the line. But let's try drawing a different kind of line. So we will draw the y and x axis, and we will draw this line. Now, what function is this? This is the function y equals x squared. It's in the shape of a parabola. Now, I'm going to pick a point and think, how do I calculate how would I calculate the slope of this point in the line? The slope would be the point where a tangent line touches the curved line. How about if I'm looking for the slope at this point? Then I would draw a tangent line that's tangent to. So those are negatives. Those would be negative slopes. How about this point? These are positive. How about the point here, which is very steep? It's extremely positive. So I have a question. Is there a way we can describe the slope of this entire line? There's no one formula for the slope of the entire line, and this is where derivatives come in. We can use derivatives to describe that. So let's go and draw a new graph. I'm going to simplify it a little. So usually we would call this f of x equals x squared. So let's describe the slope of this line. Let's think about how we can do that. We will call this point, we will just pick 2 points arbitrarily. So we have this point, we will call this point A. On the x-axis, and we will call this point A plus h. And this difference is h. So we have the values on the x-axis. Now, the y values would simply be the function value. So f of a, and this would be f of a plus h. So let's use our formula for the slope to help us with this. So it would be the difference, the change in y, delta y over delta x. So it would be f, we'll change our colors here, f of a plus h minus f of a. So that is the change in y over the change in x. So how do we calculate that? A plus h, which is here, minus a. Now you recognize immediately that the a's cancel, so we cancel the a, we cancel the a here. So now we just have h. And so let's rewrite it. F of a plus h minus f of a over h. Okay, now this actually describes the secant line here, this line going through here. But how about if we want to describe our point here? How about if we want to describe this point? How do we calculate that? Now, this is where limits come in, and I know you probably thought you would never use the limits, or you couldn't think of a reason for using limits. This is where limits come in. So what we do is we look at our h value here, and we bring our h value down and down and down until the h value is 0. And at that point, we will have our instantaneous slope. So we will rewrite this. So it would be the limit as h approaches 0 of f of a plus h minus f of a over h. And that is our definition of the derivative. Basically, the slope. You can use this to calculate the slope at any point of the line. So we've talked about how to calculate the slopes of different types of functions and the derivative and how limits aid us in calculating the derivative. Thank you.